Okay, let's do problem 11.8. This problem says that there is a shelf that is suspended by two wires here and here, and there is a tool that is placed between these two wires, and we have to find the tension in each wire. So begin by making a free body diagram of the shelf. So that's a shelf, so we want to make a free body diagram for that one. So let me draw this here. So okay, that's the shelf, and we need to make two wires. One goes like that and another goes like that. The length doesn't matter, so you don't even need to do that. So let's try to make the free body diagram by putting all the forces that are applied on this object. So one force is the tension right there. So let me call this T2 and let me call this T1. And there is a tool right in the middle of these two. So, and this applies a force of 25 Newton. So you can say lowercase mg, so mg equal to 25 Newton. There is one more force, which is the weight of the shelf, and it has to be in the midpoint between these two edges. So that means it's right about here. Okay, that's the midpoint, and that would be the weight of the shelf, which is 50 Newton. So uppercase mg equal to 50 Newton. So that's the weight of the shelf and two tensions. That's all. The distance is right here, from here to here. It's 2 meters. Actually, not 2 meters. 20 centimeters is 0.2 meters. So from here to there. If this is 0.2 and the total is 60 centimeters, which is 0.6 meters, so that means the distance between this cable and this cable is 0.4, because the total is 0.6. So if this is 0.4, then the midpoint where the tool is, then it will be 0.2 meters from here to here, and same thing here, 0.2 meters from there to there. One more distance we have to look at is, from here to here. That's the midpoint of the shelf. The shelf itself is 60 centimeters, so this should be 30 centimeters, so 0.3 meters. So that's all we have. Now we need to solve this. This is just like the problem in chapter 5, but the difference here is that you also need to look at the rotational equilibrium. So the object itself is not rotating or moving, and that's why it's in equilibrium, both linear and also rotational. So there are two equations that you can use for the all y forces, linear forces. So you can write sum of all the y equal to 0. That's one. And another equation that you can use is sum of all the torque equal to 0. So these are the two equations that you can use here. Okay, so let's look at the sum of Fy equal to 0 first. So that means all the forces in the y direction. So T1 is in y, T2 is in y, mg and uppercase mg. So these all y components of the forces, and let's do upward as positive and downward as the negative. And so I can write the sum of Fy equal to 0, this equation. So sum of Fy equal to 0 would be T1 plus T2, so upward, minus lowercase mg minus uppercase mg equal to, this whole thing in equilibrium, so that means there is no acceleration. If there was acceleration, then it would be sum of Fy equal to MAy instead of 0. So let's write 0 there. So you can write the numbers. T1 is unknown, T2 is also unknown, but then that will be equal to, this mg is 25 Newton. When it goes to the other side, it becomes positive, and plus 50 Newton. So the sum of these tensions is 75 Newton. T1 plus T2 is 75 Newton. We cannot calculate T1 and T2 separately from this equation, so we need another equation, but we have this torque equation right here. So let's get that sum of torque equal to 0. So that means you have to choose an axis of rotation. So just choose a point here or here or here or here as the point where the axis of rotation is. Let's choose this one right here, and let's suppose it will rotate like that about this axis, and we will look at what force give what kind of torque. Okay, so if you look at the torque by T1, it's right there on the axis of rotation. That means the distance from axis of rotation to where the force is applied is 0, and that's why the torque is 0. So with T1, the torque is 0. So I can write 0 plus, let's look at the torque by this lowercase mg. Again, torque is R cross F. R is the distance from where the force is being applied to where the axis of rotation is. So it's this distance. So that means I can just write 0.2 meters times the force, which is 25 Newton. That's all. That's the torque and sine of angle between them. But the sine 90, when they are perpendicular to each other, you don't have to write sine of 90. That's 1. So that's all. Let's go to this force. So again, you have to look at the distance from here to here, and that distance is 0.3 meters. From here to here, that's 0.3 meters. Oh, I forgot the direction here. So the direction of this torque, this actually tries to rotate clockwise when you have the axis of rotation there, and then this force is being applied here, then the rotation would be clockwise. So I have to write the negative sign right there. Okay, that's negative. This one is also clockwise, so clockwise is negative, and that would be the distance, the R, from the axis of rotation to the force, which is 0.3 meters, times the force, which is 50 Newton, and again sine of 90 as vertical, so you don't have to write sine of 90 there because it's 1. Now the torque by this, if the axis of rotation is here, the force is here, this force is going to rotate it counterclockwise, so you have to write plus there. And again, the distance from here to here is 0.4, 0.2, and 0.2 is 0.4. So 0.4 meters times the force, which is T2. Okay, that's all. And that's equal to 0. So this is a number, this is a number, and that's the only unknown. So T2 is the only unknown, and we want to calculate what T2 is. So if I just write this, keep it on this side and take everything else to the other side, it will look something like this: 0.4 meters, that's that, times T2 equal to this times this, and when they go to the other side they become positive. So this is positive, this is positive, so you get 0.2 meters times 25 Newton plus 0.3 times 50 Newton. Now T2 is just this number divided by 0.4. So T2 will be, if you do the calculation, so this is going to be 0.5, I'm sorry, 5, and this is going to be 15, and divide by 0.4, you will get the final. If you use the calculator, you'll get 50 Newton. So if this is 50 Newton, T2 is 50 Newton, T2 is 50 Newton, then T1 must be 25 Newton, because T1 plus T2 is 75. So if you put this T2 right there, which is 50, this 50 and 50 will cancel out, so you'll get 25 Newton. So T1 plus T2 is 75 Newton from this equation. So that means I can write T1 plus 50 Newton equal to 75 Newton. So that means T1 is 75 minus 50 is 25 Newton. So our answer is T2 is 50 Newton and T1 is 25 Newton. So that's what we were supposed to calculate. So we just calculated. So find the tension in each wire. So that's all.